integrating Flex in Java. And for those of you that don't know my blog, jamesward.com, my email address, jaward@adobe.com, contact me with questions and stuff. So that's not what we're doing. My slide got messed up. Let me give a quick overview of the difference between the two products, Blaze DS and Lifecycle Data Services. So Lifecycle Data Services has been around since Flex 2. It was originally called Flex Data Services. And really what it is, it's a more efficient way to communicate between your Flex front end, whether that's in the browser or in Air on the desktop. It's a more efficient way to communicate between those front-end client-side applications and your back-end Java app server. And it also has some additional functionality as well for that communication. So Blaze was recently, we took a part of Lifecycle Data Services and we open sourced it as Blaze DS. So there's two major pieces that are part of Blaze, the remoting and the messaging, and we're going to show some demos, write some code for how to use those two pieces for those of you that aren't familiar with those. So that's real quick overview, differences between Blaze and Lifecycle Data Services. You can go download Blaze today, play with it. All it is some jar files you dump into your war file and some config files, and that's it. Actually I haven't posted it yet. I will post a blog right after this session with some links to where to get Blaze, an article that walks through a lot of what I'm going to go through tonight that I wrote on infoq.com. So that'll go up on my blog later tonight, and so you guys, if you want to go back and find these resources, and hopefully I'll eventually post the recorded version of this as well on my blog. So hopefully it picks up my voice. So so you can go download Blaze, and you can also go download Lifecycle Data Services Express. That's a version of Lifecycle Data Services that's free on a single CPU. So that's good to kind of try it out. There's something called the test drive that walks you through how to begin using Lifecycle Data Services. So you can go download that Express version and play with Lifecycle Data Services and play with the data management feature that we're going to talk about in a little bit. You can go play with that if you want. So there's really 4 different kind of ways that we're going to look at how we integrate our Flex front ends with Java backends. So the first way that we're going to look at doing this is, let's say that we have an existing infrastructure. We have struts on our backend already, or some JSF, some other technology, and we don't want to completely kind of dump all that stuff that's already there. So what we can do is actually just expose that stuff through XML to Flex, and then Flex can consume that. So let me stop and show you an example of how we would do that. So the first thing I want to show here is I have this catalog JSP file. And this JSP file lives on my server in JBoss in this case. And all it does is it does some JVC and makes a request to my local database, then outputs XML. So this is Firefox rendering of XML. Let's go look at the source code here. So that's our XML. So that XML is something that is very easy for Flex to consume. So if we have struts, JSP, whatever, we can easily, instead of outputting HTML, output XML, and have that XML be something that on the Flex side we then parse and pull into memory. So let's go do exactly that. So I'm going to create a new Flex project. I'm in Eclipse with the Flex Builder plugin installed. Seems like probably all you guys are familiar, but just in case you guys aren't, Flex Builder is a plugin to Eclipse. It's commercial. You don't have to use Flex Builder. You can use VI. That's my favorite IDE, and the open source Flex SDK. So you don't have to have Flex Builder to do what I'm showing you tonight. So let's create our project. We'll call it catalog. And in this case, we don't need any particular backend. And it's just going to be a web application rather than a desktop application. So here's our base project, and this is what the start of every Flex application will look like. I delete that layout absolute because it's not necessary in this case. And so this is our base application, and we're going to connect to that XML file and get its data. So we do that with the HTTP service, and give it an ID, set the URL to that URL to my JSP file, and then let's get a data grid in there so that we can see our data. And then we're going to use a binding expression, so we're going to tell this application, watch this particular variable for changes, whatever we're binding to, and when it sees changes, when it sees that variable change, it's going to refresh its view of its data. So maybe review to some of you. And so there's our what we're going to bind to is the service, the last result that we got back from the request to that service, and then we actually have to traverse down to the objects that we want to display. So if we go look at our XML, we'll see that there's a catalog node and then an array of product nodes. And really what we want to display in our data grid is that array of products. So we're just going to traverse down, catalog dot product, and that will tell our data grid to display that list of products. And the last thing here, we need to add an event handler. So events are just baked into all the components in Flex. Every component emits events. Application complete is an event that gets emitted by the application object. So when our application is fully initialized, it throws this application complete event along with a bunch of other events along the way, and we can handle that event and say when we get that event, we want to call srv.send. Then we save that, and then we can go run this. This runs in our browser. Once it's hello. Computer is not working. Launching catalog. Thank you. Weird. What did I do wrong? Let's try it. That's going to be, maybe I need to be patient. Okay. Yeah, it could be. Let it work for a second. So when this launches, it's just going to run the application on the client side, make the request to that JSP file, and when it makes that request, that will go across the network over HTTP. Then that JSP will output that XML. We take that XML and consume it in our Flex application, and then render it in the data grid. And I don't know why that's not working. Let's try something here. Let's go change our browser. Try IE. All right. We restart Flex Builder. That's probably your bug. And you can't even fix it for us now because you're not engineering anymore. All right, let's try again. Run as Flex application. Launching. We're getting further. Oh, build before launch. There we go. Oh yeah. We just needed a restart. Okay, so there's our data grid with our data. So that made the request to the server, to the JSP, where it fetched the data from the database and then gave us our rows back. And this is, our good old Flex data grid with all its cool features. So that is our basic way of integrating with a Java backend. And I'm going to go switch my browser back real quick because in IE I'm running Flash Player 10 beta, and we don't know what's going to happen in Flash Player 10 beta. So that's our basic application talking to Java backend. Any questions so far about that method of communication? Okay, pretty straightforward. Probably review for all of you. So there are some reasons why we would want to use that method, but in most scenarios, I'd say it's much more efficient to use an optimized protocol for communicating between the client and the server. I remember I was hanging out with the JBoss folks at Java 1 or something like that, and Mark Fleury, I don't know if any of you guys have met him, but he tends to go off on these tirades, just screaming about stuff, and he's French, so he likes to scream about just things that make no sense. So he was talking about how, this is long ago, he was talking about how JBoss was such a great app server because in JBoss, they put in like 3 lines of code that said if you're making a remote EJB call and that call is is in the same container, so it's actually a local call, then rather than make the remote call and do all the serialization, all the RMI overhead, then let's avoid all that serialization and let's just make it a local call instead. And he said, it was like 3 lines of code in JBoss to do that, and it saves a whole lot of the performance problems that you run into with unnecessary serialization. So moral of the story was, don't do unnecessary serialization if you don't have to. And I call it Mark Fleuryism number 392. It's in a book somewhere. It's all his Mark Fleuryisms. And I subscribe to that particular Mark Fleuryism. So this is a demo that shows why that's important. And what it does is it compares a lot of different methods for doing data loading in rich internet applications. You can find it on my blog, jamesward.com/census. And I won't go through all this, but I do want to show you, I won't do the Ajax one that I usually do, but I want to show you the XML one. Since we just loaded some data over XML, we're going to do something very similar here. We'll do 5,000 rows. So what's going to happen is we're going to make a request to my server. This is in California. It's going to output XML just as we saw before with the JSP. And then actually I've got gzip on top of that. So in a servlet filter, I'm gzipping down that XML because we don't want to transfer that giant block of XML across the wire. So you can toggle gzip on and off if you want. But gzip is on right now. So we're going to compress all that text down. We're going to transfer it across the wire. And then on the client side, we have to uncompress the gzip stream. We have to take all the XML, parse it, and then we're going to render the data. So let's run that with 5,000 rows. So this is Flex. This is going to be, if you look at the other Ajax methods, Flex is faster than all the Ajax methods, but, and there's a bug in Firefox 3. I actually have to click over here. Got to fix that. So that's going. We get our 5,000 rows, and here's our total amount of time to get that 5,000 rows for my server to actually take that 5,000 rows of XML and serialize it into or pull it from the database, turn it into XML, and gzip it. Took my server almost 2 seconds to do that. So that's a lot of latency there. Then the amount of time to transfer that 50K across the wire was around 1 second. Then the parse time, even though we've got the super fast JITted virtual machine on the client, I'm pretty sure our XML parsing methods are even written in C. So super fast parsing that 5,000 rows still took about a second. And then render time, it did take us 150 milliseconds or so once we got the data into objects in memory to actually render that 5,000 rows into the Flex data grid. So here's our Flex data grid, here's our 5,000 rows. Okay, so let's go look at the AMF version. So this is going to do something very similar, make the same request to the same backend, and we're going to, instead of turn it into that text-based XML, we're going to turn it into binary objects. So we're going to turn it into the actual bytecode format, the binary format for Flash Player's objects. So that then there's a couple things that are better about this, which you'll see. And let's actually run it and then we'll talk about it. So let's run this with this 5,000, and we got to switch over there so it loads the iframe. So there we go. That happened in 1.4 seconds total, and you'll see that the server execution time went from about 2 seconds down to 64 milliseconds because we're operating in memory. We're not turning things into strings. We're not gzipping strings. We actually did even do a gzip on top of that, but AMF has a built-in compression capability into it. So basically it says, hey, if I've already put a value into this stream, I'm not going to put that same value in again. I'm just going to put a reference to that value. So built-in compression, so gzip doesn't have to do a lot of work here. Yeah, question?
When you use the AMF protocol, do you actually send an XML object that actually script XML or
It actually ends up being like not array collections, but arrays, primitive objects, and numbers. What are our other primitives? Booleans. So that's what it actually is turned that stuff on the server into those binary objects, and then when it gets to the client, there's some type information in there. So if we want we have type information on the Java side, like this is a person value object, we can actually, when it gets to the client, we can actually turn it into the person value object on the client because that type of information is in that stream of data. So across the wire, it just, for the most part, just looks like objects and arrays, but it does have the type information in the stream, so it knows how, if you have the client-side value objects created, then it knows how to deserialize them correctly. You don't, if you didn't create those, then they're just going to be the primitive arrays and objects. Yeah, so that.
So to get this advantage, the only thing you have to do is switch to the AMF protocol?
Yep, that's right. Yep. So rather than using XML as your serialization, use AMF. And I'll show you an example in a second where we use where we build an application that does AMF as a serialization. Yeah, question.
So the thing about this, most of the process of using AMF is on the server side, and it's more or less the same size because it also takes 1 second to respond to offline, but the rendering takes slightly longer.
Yeah, good question. So the rendering did take longer, and I believe that the reason for that, you look at the parse time here, there actually is some parse time going on. My problem was that I couldn't figure out the right place to get my event handler to say, all right, that's exactly when it started parsing. So I believe that some of that render time in this case is actually part of the parse. So it does take 100 milliseconds in this case or so to actually take that binary data and get it into memory. It doesn't happen instantaneously like my chart is saying. So that's a little misleading, but which I'm working on fixing for the next version. But so render time should be the exact same because once we get those objects into memory. The other thing that you're seeing is faster. Any way we look at it is the actual client side parse time. So we're not having to do a whole lot of work to parse that data because it's already in the binary format. So that's the other place where we're saving it, both on the server side encoding and on the client side decoding. So that's the primary ways that we're saving with AMF. Yeah, and I always like to run this one with all 20,000 records in my database and see how fast that is based on our network connection. Oh, you guys click over here. Let's go. So 20,000 rows. We'll see we didn't get a whole lot longer. This is 4 times the amount of data, and that was 222 milliseconds, about four times what it took before. Transfer time was actually a little bit faster. Maybe the network got faster all of a sudden or something. Parse time, again, that's wrong in this case. Render time actually is about the same. So as your data sets get larger, it doesn't take a whole lot more time to do that parse and render. Because everything's kind of happening in memory with binary objects. So, other questions about that? Okay, so let's take a look at how we actually begin building applications that use AMF. So, I have my war file here. This is my WebInf folder on my war file, and I want to show you first of all a Java class. Find the right one. Here we go. So I've got this census service Java class, and this is just a POJO Java class. It's actually exactly what I'm using on my server in the demo that we just saw. In this case, it's all running local in JBoss. And this is just a really simple POJO. This could be a Spring Bean, it could be an EJB session bean, whatever we want to use here. It doesn't matter to Blaze or Lifecycle data services. So we've got our Java class, and it's got a method on it, getElements. Takes 2 parameters, a begin and a count. And then what we're going to do is we're going to go through, we're going to do a JDBC select, we're going to go through, add our value objects to a list, and then just return those. So really, really simple stuff there, getting data from a database. So what we want to do is expose that Java object as a destination. Destination is like an endpoint. Think of, I'm going to talk a lot about destinations tonight. So think about them as just an endpoint. This is a way to connect to that object. So we will need to create a destination for this Java object. So we do that through a config file. We have this remoting configuration file. This is part of Blaze or Lifecycle Data Services. And you'll see in here this destination that defines, first of all, an ID says this is how you're gonna select that destination is through the ID, and then it says the source, the class file that we're going to use to do this remoting to. And again, could be an EJB session bean, could be a string bean, whatever you have on your back end. So before I go on, I want to compare this a little bit with the JSP method. Typically in our struct-based applications, we had our controllers, we had our JSPs or whatever for our views, and our controllers were probably behind some kind of services layer, possibly EJB, Spring, there was probably something there that created some sort of a services layer, hopefully. So if that's true, then if you wanted to build AMF into your application, rather than doing the XML serialization that we saw before, what you would actually do is just take that services layer and expose those services, that services layer as destinations. Or maybe you want to put some thin proxy layer on front of that. It's up to you. But you want to take that services layer and expose directly to that services layer as your destinations. So that's what we've done here. So now let's build our client-side Flex code to talk to that destination. So we'll call this one census test. Oop, and I need to select, hey, I'm going to use a J2E server this time. And it's saying, hey, do you want to use remote object access service? Yes, I do. And it says lifecycle data services here, but it also applies to Blaze as well. So even though it says lifecycle, it works with Blaze. So then we specify some parameters. Where's our web application? What's the context root? What's the URL? And then we can hit finish. So again, here's our basic Flex application. And so in our basic Flex application, what we're first going to add is a remote object. And this is going to facilitate all that communication between the client side and the server side over AMF, or using AMF over HTTP. That's how it's going to communicate. And it's going to be talking to a servlet in our web application, in our WAR file, that's going to do it's going to instantiate that object for us on the server, going to invoke the method call, going to take the results, serialize them into AMF, and send them across the wire. So we'll give that an ID, and then we need to specify the destination. We'll call it census, or we won't call it census. We will refer to census, which matches this here. And then let's add just our plain old data grid and set the data provider on our data grid. So now we're going to tell it to bind to. Now what we're actually going to bind to is going to be the kind of convention for a remote object is the first of all the remote object, and then the method that we called is going to be a property on this object, so get elements, and then dot last result is going to be the last thing that we got back from the call to that. If we didn't want to do data binding, we could also set a result event handler on the remote object itself and get the results out that way. So you don't have to do it this way. There's lots of different ways to do this to your liking. So then, last thing, let's add our application complete event handler. And now we're actually going to make that method call. So we actually make the method call like it's a local call. So we call our remote object get elements. So we invoke that function on the remote object. The remote object is a dynamic object, so it says, hey, it looks like you're trying to invoke this function that isn't on me, must be on the server. So then it makes the HTTP call to the server, calls the servlet, which instantiates the object, makes the method call on that object or Spring Bean, whatever you have, and then does the AMF and goes back to sends the response back to the client. So let's pass it our variables. We'll do all 20,000. Those were the two parameters that it took. So we can go verify that. Here's our get elements with the beginning of the count. And you'll see that we're just sending primitives in this case, but these could be fully typed objects. You can send fully typed objects back and forth. If we wanted to send a person value object in either direction, that totally works. So now let's go give this a go. So now this is going to execute here on the client, make that method call, and there we go. We got all 20,000 rows. So just in case you blinked, you didn't see it, 20,000 rows. Here we go. Again, there's no network transfer, but that's pretty darn fast for being able to load an application and render 20,000 rows. So there we go. Here's all 20,000 rows. We can do fun things like client-side sorting instantaneously and all that kind of stuff. So you can experiment with all that on the Census app on your own. So that's really simple remoting. This is all RPC style communication. So in your application, let's say you want to do CRUD operations. I want to create this object. I want to update this object. I want to delete an object. This is RPC. I'm making a remote command to the server. The server is doing something and giving me a response, either a result, yeah, it worked, or a fault that didn't work. So keep that in mind as we go to the data management service, where then we're not doing RPC, we're doing more like Hibernate style modifications of data. So keep that in mind for in a little bit. So that's remoting. Any questions about remoting before I jump ahead? Yeah.
Currently, we're using Backend typically on the server side, but they have no
Right.
and we're able to test their own services as well. How would you suggest to do something remote workload?
Yeah, that's a good question. So there's kind of two answers to that. First one is that you having a service exposed as AMF doesn't say that you can't also have a SOAP way to get to that same service. So a lot of times that's what people do. Let's say that I have an EJB session bean. I'm going to go annotate that EJB session bean as @web service. That exposes it as my web service. Then I'm also going to go create a destination in my Flex config file that remotes directly to that same EJB session view. So now I've provided two different serialization methods to get to the same service. That would allow them to still test over SOAP. Would also allow like partners that aren't necessarily using Flex to also get to those services as well. So like Salesforce.com, obviously they can't just provide an AMF library where they don't provide an AMF library, they provide a SOAP library. But they could also provide an AMF endpoint to their same services as well. So, and I believe that Business Objects is doing that sort of thing, where you can kind of select, do I want to use AMF, do I want to use SOAP, do I want to use REST, pick your serialization technology. It's all going to the same backend services. The second answer to that is, which brings up a good point, is testing. How do I test AMF? It's binary objects across the wire. How do I do load testing and those sorts of things? And we do have automated testing tools that vendors that we've partnered with that can do testing of the AMF stuff. Silk Test is one, and there are a couple others out there as well. So if people say, the AMF sounds cool, but I need to be able to test it, we can definitely do that as well. So, good question. Other questions? Okay. So that was remoting. Talked about remoting. The second major feature of Blaze and Lifecycle Data Services is messaging. This is where we have an application that it's not, we don't want to make the RPC style calls. We want to do more of like a JMS topic, where we've got a client application and we want it to publish messages to a message topic and also subscribe to messages from that topic as well. So to publish and subscribe to API, a producer-consumer style way of doing communication between client and server. So usually you would use the RPC style and the messaging style in a typical application. Let's say that something happens on the back end, you need to notify your user in an asynchronous way. You can do that sort of thing. You can also do like collaboration, like two users collaborating together. One user clicks on something and the other person sees something happen on their screen. So all those sorts of scenarios are possible through setting up messaging. So the way it works, client sends a message to the message service. By default, the message service runs standalone. So what that means is that it's only for Flex client to Flex client communication. And if you have some other messaging system, then like JMS, you can actually attach that message, the Flex message service, to your JMS message service. So then what actually happens is the Flex message service becomes a client of your JMS system. So that means that you can now have your Flex client send messages to the Flex message service, which then get relayed into your JMS system. Or the other way around, you can have JMS messages come that your message service is listening for messages on, send messages to the message service, and then those get pushed out to the Flex client. So and then we support any kind of, this is an open adapter architecture, so if you don't have JMS, if you have some other type of messaging system, you can build a little adapter that will allow you to hook the message service to that messaging system. So let's write a quick example of using that message service. So in this one, the first thing that we need to do is set up our destination. So anytime in Flex, when we're connecting to something on the back end, we need a destination. So there's the messaging config file, and we'll see in here that there's already a destination set up for us called chat. And that's going to be the one we're going to use. It's not hooked. There will be some other parameters in here if it's hooked up to JMS. This one is not hooked up to JMS. I don't know. There might be one in here hooked up to JMS. Let's go see. No, it doesn't look like it. So there's some examples on the web of how to hook it to JMS, but none of these are hooked to JMS in this case. So we can specify some properties about how this particular destination behaves. You know, networking properties like durability of messages and those sorts of things in this destination. So we have our destination. Now let's go create a new project. We'll call this one chat test. And again, we're going to use our J2E server, create our application, and clean this up. So now here in our chat application, we need really 5 major components. We need to be able to listen for messages. We need to be able to send messages. We need to be able to have some way to see the messages that are being sent, some way to enter a new message, and some way to initiate the send of that message. So 5 components. We'll add those real quickly. The first is a consumer. We'll give it an ID, and we're going to specify the destination to connect to, which was chat. So that's going to allow us to consume messages from the server. And we're also going to add a producer, and we'll call this one prod. And again, the destination is chat. Then we need that text area so that we can see the chat messages which have been sent. Call this MSG, and let's see, 300 by 300, so we have lots of room for messages. Then let's add a text input field, which will be how we send a message. So we'll just say C for the ID. And then let's add a button with the label of send and a quick event handler. So we'll fill that in a second. So there's a few things that we need now to actually hook up the plumbing of this application. This is our base application, and if we want to actually make this start listening for messages, what we need to do is tell this application, when you initialize, start listening for messages. So we do cons.subscribe. So that begins listening on the server for changes or for messages. Then when we get a message, we want to be able to actually do something with it. So now we add a message event handler to our consumer. So when we get a message, what we want to do is take our messages object, which has a text property, which is just the text of that component. We're going to append onto that object event. So when we get a message event, there's an event property there. It has on it a message property with the actual message that was sent, and then we want to append on the actual body of the message, what was actually sent in the body of that message. So then we'll make it nice by adding a new line character there, and then so that's going to allow us to receive messages. That's all we need to do. We're now listening for messages when this application starts up. So now to send messages, we've got that click event handler on the button. So when the user clicks that button, we want to do the send. So what we're going to do is we're going to tell the producer, hey, send a message. And you'll see that it's asking for, its parameter here is something of type iMessage. So async message is an object that implements that iMessage interface. So that's the type of message that we're going to send, an async message. And then the constructor of async message takes a parameter for what do you want the body of the message to be. In this case, we want it to be c.text. So we want to send what the user has entered into that bottom text input. We want that to be the body of the actual message. and then close that. And there's a little bug in Flex Builder here. It didn't auto import my async message for me, so I need to get it to import async message. There we go. So async message is the class that we're using here, so we need to import that. So it added that for us. There we go. Okay. So now let's save that, and looks like we didn't get any compilers. That's good. Let's run it. So let's give it a try. Test. There we go. We got our test message. So we don't know for sure if that actually sent to the server and back. Maybe I'm playing tricks on you. So let's actually test it by opening up another browser window. So we'll say do 2 clients. So this has to go across the network. And we'll say hello. And there we go. So now we're sending messages back and forth across the server. We can send that again and sending messages to the server. The clients are listening for those messages. So there's a lot of different ways that we can actually push those messages to the client. We have 4 primary channels. Interestingly, you haven't seen any configuration about, comment, how are we doing this? Are we using some binary socket? That's all decoupled from the actual definition of our messaging stuff. So there's 4 different channels that you can use to actually communicate over between the client and the server. So you guys are probably all familiar with the fact that a server can't just initiate some connection to the client. So the client has to initiate the connection. There's a lot of different ways that we could do that. The 4 ways that we've implemented are, first, a protocol called RTMP. This is a non-HTTP based protocol. It was really created for doing flash video streaming, and we just use it for streaming data. So RTMP is good because it's low latency. It nails open a connection. We don't have to do polling against the server. We're using NIO on the server to be able to scale really well. So there's a lot of advantages to RTMP. There's also some disadvantages. It's not HTTP based, so we have to deal with some session binding stuff so that we can identify the user requests and authenticate them. It also may require firewall changes and those sorts of things. So RTMP may or may not work in your scenario. If it doesn't, that's great. You have 3 other options to choose from. And the server will even fail over. So you can say, I want you to first try to make an RTMP connection, and if that doesn't work, then fail over to the next one that I've defined. So the next one is streaming HTTP. So this actually opens an HTTP connection and then just streams stuff down over HTTP. It's NIO based. Actually, we have two different methods: NIO backed and a non-NIO backed, which just uses the browser HTTP servlet connection. So you can choose either one of those methods, streaming or streaming with NIO or streaming just through the basic web server HTTP connection. Then the last one is polling, and in the polling model, essentially what it's doing, the client is saying, hey server, do you have anything for me? And the server is responding and saying, no, I don't have anything for you. There's 2 different configuration parameters that you can tweak on the polling channel to determine how often you want things to happen. So in a traditional comment style communication, what happens is the client makes a request to the server. The server is going to, if it has something to say, it will immediately tell it respond back to the client. But if it doesn't have anything to say, it's going to keep that connection open for some amount of time you specify. Let's say 30 seconds. So you're actually holding open a connection on your server for that 30 seconds, and then after that 30 seconds, the server is going to respond back to the client and say, I don't have anything to say to you. And then the client also has a parameter for how long it waits before it initiates another connection back to the server. So you can then tell the client, hey, I want you to wait another 30 seconds after you get a response before you initiate another poll back to the server. And so there's those 2 different options. You can balance them depending on how your network configuration needs to be and what size of messages and how frequently they need to send and all those different variables. It's all customizable. So all those 4 different channels are customizable for how you want them to work. It's hard to say which one is the best because it really depends on your scenario. But should also point out the RTMP and NIO backed streaming, HTTP streaming, are only currently in lifecycle data services. So the other channels, the HTTP streaming, non-NIO backed. The reason why we don't have an NIO back right now is because we're on the Servlet 3 spec, which is currently adding the formal way of doing NIO-backed connections in the app servers, in the Java app servers. So we're waiting for that standard to be finalized before we implement our version of that in Blaze. So currently in Blaze you have the streaming without NIO and you have the polling. And then I think there's some open source projects that are going on right now to use Blaze because it's open source and use like Tomcat 6's new NIO connections or Jetty's NIO connections. So there's some interesting stuff going on there if you really want to use the streaming channel and you want NIO. So if you're not using NIO and you are using streaming, you need to be really careful because Tomcat has a limit of, tell me what's the upper limit of Tomcat's number of concurrent connections. It's really low, it's like 256 or something like that. So that would mean you get 256 concurrent connections on each box. So that's not good. And so you would need to do something about that if you're not using NIO. Okay, questions about channel stuff, about messaging stuff? Yeah?
All of these methods seem to me rather problematic with large amounts of customers. For example, if you have the calling mechanism,
Yeah.
Which is loading the server, and also the HTTP streaming also keeps the connection open here.
Yeah.
So I would assume if you have lots of concurrent users, that all of these options streaming would be kind of a problem.
That's totally true, unless you're using NIO-backed connections. With NIO-backed connections, you actually can it's not a thread per connection correspondence. So you're actually not using nearly as many resources when you're using NIO-backed connections. So we would definitely recommend that if you need large scalability, that you need to go with something NIO-backed. And again, if you're using Blaze, then today you're going to have to do some work and probably cooperate on some of the open source projects to get the NIO support for Blaze working. Using lifecycle data services, then you get the NIO with RTMP or with HTTP streaming. So yeah, but you're absolutely right. Tomcat, like I said before, Tomcat's out of the box connection limit is very, very low, and you would really quickly max that out if you're not using NIO. Other questions on that stuff? Okay. This all review for you guys, or you learn anything new? A little bit new? Okay. All right. Okay. So let's go on to the next method here. So we talked about kind of the two basic kind of fundamental pieces for doing communication back to our Java backend. First the RPC and the remoting, and the messaging. But neither of those really address kind of the way that I look at this is that when we started writing Java to connect to databases, we're all doing JDBC. It's very RPC style operations back to the database. We say, I want to do a select, I want to do an update or an insert or delete. And then, of course, Hibernate and all these other frameworks arose to kind of get us away from doing that RPC style fashion of communicating back between the middle tier and the database. So I look at data management as being kind of like that same thing, but for the synchronization of data between the client and our app server. So we have that piece where we can do RPC, we can do the CRUD operations, we can keep track of changes, we can do commits and rollbacks, we can kind of build all that stuff over RPC. But really what we want to do is we want to have a programming model that's more like Hibernate, where I just get this data, I send it to the client, I do operations on the client, and those operations automatically get synced to my backend for me. And we also want to make sure that all the clients that have that data set are also being synchronized as well. So we want to make sure that as a client is making changes, that those changes are being pushed out to the other clients that have that data set on them, so that everyone's in sync. So that's what the data management service in Lifecycle Data Services is for. So I can make a change that goes through the data service, goes through this assembler or adapter layer. Those adapters can be a number of different things. They can be just POJO objects. All these adapters are doing is saying, all right, I know that there's 4 operations that happen on my objects. They're the CRUD operations. I need to map those CRUD operations back to my actual business logic, or my actual logic that's actually talking to the database or the service layer, whatever. It needs to map to the thing that's actually, map those CRUD operations to the thing that's actually doing the work. So you put in a small kind of proxy layer here, and if you're using Hibernate, it's done for you. You just say, here's my Hibernate configuration, and it knows everything about how to do those CRUD operations automatically, so that saves you some time. If you're not using Hibernate, then you can build this object adapter that again just maps those CRUD operations to your backend. So you make that change, goes through that kind of proxy layer, goes through your backend, JDBC, whatever, commits to your database, and once that commit has been successfully completed, then the data management service actually then takes that change and pushes that change out to all the other clients that have that data set on them. So the service is actually managing, hey, this client with this ID has this version of the data on it, this client has this version of the data on it. There's different parameters you can specify about how you do caching on the server, and whether you're just caching primary keys, or there's a lot of different ways you can configure that. You know, if you have large data sets with millions of records, you certainly don't want to be caching all that information on the server, and there's ways that you can deal with that. So let's build a quick example that does data management. And so this example, we first need, again, our configuration. So let's go look at our data management config. So we have a destination that's created, CRM-employee, which is going to map to this Java object, which I won't show you because we're running short on time. But it's just a Java object that just maps those CRUD operations back to, in this case, a DAO that does the JDBC. We tell it, hey, my primary key is employee ID. We specify some other networking parameters there. So that's the destination that we're going to use. Now let's go create our Flex project. So this one we're going to call EMP Web for web, and you'll see why in a second. So again, our basic Flex application. Before I write some code though, in order for the data management service to work, we have to know about our domain model on the client. So in order to do that, we've already created, for this example, a POJO, which I'm just going to copy in, or in this case it's not a POJO, but an ActionScript object. So you can code gen these out if you want based on your POJOs. But all this is a ActionScript object that just looks like our backend Java object. So we could again code gen these if we want. This is just a really simple employee value object, you know, on the client, for the client side. We need to have that for the data management service to be able to know what this object looks like and how to synchronize it correctly. So that's why we copied that in there. So let's go. We need to first add that employee to our application. So we just add that in. And then we add an array collection to our application. So this is going to hold all of our employees. So we say ID employees. And then we need to add our data service and set the data, not data provider. We set the destination. First we need an ID on this, but yes. Then we need to set the destination to that CRM-employee destination that was defined in that config file. And then we're going to set our data grid with the data provider binding to employees. And then we're going to tell this data grid to be editable. So that's our whole application. It's going to do all these CRUD operations. We've just taken all the kind of RPC code that it would take to do all the CRUD operations, track changes, you know, push updates to clients, and we move that into this single data service tag that handles all that stuff for you. It has conflict management, has commit, rollback, all those sorts of things just built into it, just like you would find with Hibernate style way of manipulating data. So then last thing let's tell our application here on startup to fill our employees array collection. So it's going to fill that employees array collection with managed objects from the server. So it's going to take all the employees from the server and copy them across to the client, and now those are managed objects. Anytime we make a change to those objects, it's going to know, and it's going to then tell the server, hey, there was an update or a delete or an insert. It's going to know those changes and tell the server about those, and then if those commit successfully, those will be pushed out to the other clients that have that same data set on them. So let's save that and see if it works. So here's our basic application here. There's our employees from the server, so it's just fetched from the server. Now we can make some changes to the data. So we don't really know at this point, are these changes really being committed? As soon as I click out of that cell, it's supposed to be committing those changes to the server. That's the way that the data grid just functions out of the box. You can customize that if you want. But out of the box, as soon as I click out of the cell, it should notice, hey, a change happened, and I want to commit that change to the server. So in order to see that this is actually working, let's create a new window here. So we're going to simulate two clients interacting with that same data set. And we're using the same messaging channels that we used for chat. We're using those same channels here to do real-time push. So when I make a change to this data and click out of that cell, you see that change got pushed to that other client, or to all the clients that have that data set on them. So we can do that again in case you blink again. So there we go. We're doing data management. We can do it both ways here. So those are CRUD operations on the client that are just going to my backend objects and then persisting to my backend database and pushing out to all the clients. So cool stuff. Yes. If they're what? Right. Yeah. If they're in memory. So if the user has gone to Google and off of this application, then the application actually has to be running. But if the application is running, then yeah. And you can customize that. So if you want to say, I don't want to listen for updates because the user is totally somewhere else in the application, then you can say, I don't want to listen, and then as soon as the user comes back to this portion, you can say, all right, now send me all the updates that are pending. So you can customize how that works. It's up to you. Yeah. Yeah. Oh yeah, that's a great point. That's a great point. So I'm using the same application here, but actually I can actually show that because I do have another application that's actually, let me go find it, is actually using the same exact data set, same exact destination, CRM mini. Oh no, these are companies. Okay, I've got a different one. 1 second. There we go. Okay, so this one is a totally different application that's using that same CRM-employee destination. So let me go see if I can find these employees. Anna, do we see Anna? We should see Anna somewhere. There she is. There's Anna. Okay, so Anna over here, let's see if we can watch her phone number change. I've never tried this, but it should work according to Closky. Okay, so if we change this data here, if I delete that and then click out of that cell, there we go. We updated the data in the other application. So because the data management services is just based on a destination, both these applications are connecting to the same destination. Yeah. In this case, I hand coded it, but there's xDoclet tasks. There's a couple open source libraries out there that do the code gen for you. Yeah, email me if you can't find them. It's been a while since I looked for them, but I know they're out there. xDoclet's kind of old, and no one wants to use xDoclet anymore. There are some other ones out there. Yeah, I can point you to them if you can't find them. Okay, so we've got our different applications, but what if we haven't talked a lot about Air, which is our new desktop runtime. Yeah, question?
Just
Yep. Yeah, I usually gloss over that because it's magic. No, so what happens here is that I need my application to have a reference to my employee value object. Otherwise, that bytecode for the employee value object is not going to end up in the Swift. And then when that AMF data comes from the server to the client or client to the server, it's not going to know what an employee is. It's going to just be a type object. So I put a reference there. This is actually kind of the really bad way to do it. I'll show you the right way to do it. The right way to do it is to, let's say, public, let's make it private. Private function foo if 0, then var employee equals new employee. So that's the better way to get the bytecode into that. Most of the time in your application, I should say, you're going to have a reference to the employee value object somewhere. In this application, because it's very, very small, I don't have any references to employee anywhere in my code. Most of the time in real applications, you'll have references to your value objects in your application. You don't have to worry about this. If for some reason you don't have any references to it, then that's not going to be linked into your output into a file. You have to get that linked in, and so this is the way to do it without any memory overhead. Make sense? Or totally confused everybody? Okay. Okay, so we need to go back here. So we haven't talked a lot about desktop applications, but we now have, with the Adobe Air, Adobe Integrated Runtime, the ability to take web applications and run them as desktop applications. We can do that because we want to do offline data caching. We want to be able to do native drag and drop. We want to be able to do system notifications. All sorts of reasons for wanting to build a desktop application rather than or in addition to your web application. Parlays.com is a great example of why you want the offline available Air version and the online Flex version. So we can do cool things with Air, but what about data management? Can we do data management with Air? Oh, well, of course. Let's do a little demo. This time we're going to select to be an Air application, and we'll hit finish. So I'm going to do the really kind of poor man's way of code reuse. There's much better ways to reuse code, but I'm going to do it really poorly. I'm going to copy and paste all the code from my employee EMP web project. We're just going to copy and paste this all into this project. Again, don't take this as best practice. Best practices are the next session. So copy and paste, and now we have a desktop application which will do data management. So let's see. So here we go. We've got our desktop application. There's System Chrome. We can do all those cool Air things. We can do offline data caching. But let's see if our data management still works. So let's enter a value here. And hey, cool. So we're syncing data between a desktop application, a web application, and even another web application. You guys aren't impressed, but that's okay. That's cool. I have more. It can just keep going. Okay, so we're going to actually do something kind of crazy. We're going to go create a PDF. And in this PDF, what I'm going to do is I'm going to go find the Swift file, the actual application here. Here's my Swift file. I'll get that URL. We're going to take the URL for our Swift file, and I'm going to go to my PDF, and I'm going to tell it I'd like to insert a Flash file into this particular application, and let's tell it to start working when the page is visible. Okay, so it is now going to embed that Swift file. Should be downloading it and embedding that Swift file into our PDF. So now, when the user opens, you send this PDF to someone, they open it, and oh, I just got my data with my Flex application inside of a document. And even better, let's say that we've got all these different clients, all interacting with this data service. I don't even know where my windows are anymore. Okay, here we go. Here's my PDF. Need to make sure I can see all these. Move this one over. Okay, I've got my PDF. You guys, I've already ruined it. You guys already know exactly what's going to happen here. We've got, who was it? Anna. Let's go edit Anna's phone number here. Click out, and yeah, we're doing data synchronization, PDF, air, web, blah blah blah, fun stuff. Okay, so that's fun stuff. That's the data management service.